Hi, this is Scott. I really appreciate our sponsors because they make the show possible. Today's show is sponsored by Developer Express. Become a UI superhero with Dev Express controls and libraries. Deliver elegant .NET solutions that address customer needs today. By leveraging your existing knowledge, you can build next-generation touch-enabled solutions for tomorrow. You can download your free 30-day trial at dx.hanselminutes.com. That's dx.hanselminutes.com. Hi, this is Scott Hanselman. This is another episode of Hansel Minutes. Today I'm talking with Kelsey Hightower from Google. How's it going, sir?
Awesome. Glad to be here.
Thanks for hanging out. So we work on OSCON together, which is cool.
Yes, like dynamic duo.
Yeah, and we did pretty good last year.
Yeah, I think so. I learned a lot, and we brought hip hop to OSCON, which was just new.
We did. We had Samus come to OSCON. You can check her out, SAMMUS, Samus Music. I think people may have had an idea about who was the person who brought Samus.
Yes, there was a bit of concern that would be Kelsey's idea, but yet that was Scott's deep integration with the community. I like the way Scott has a diverse group of folks that he knows, from hip-hop artists, people that make things, people that build things. I love it.
Well, this is why we're such a good team, and why I think OSCON this year will be pretty sweet too, because we've got makers and you've got people building and committing real code to GitHub, doing real work.
It also feels like the people we meet in real life, we figure out, hey, you're good at a thing, you should be at OSCON. And we have a platform to make it happen now.
No, that's a good point. We don't go looking for people that are like, hey, you're a professional speaker. Come speak professionally at OSCON.
Yeah, exactly.
Like, you're building something cool.
Yeah, and you should have a stage. I think we always talk about, how do we give people the ability to show off their craft? How do we give them some spotlight? How do we share the stage? And I think for the last couple of years, OSCON has been that thing we could do to put someone on stage for the first time. Yeah,
that's cool. And OSCON, of course, is coming up. So go and check that out, and be sure to scroll down when you get to that OSCON page, because there's lots of discounts for students, for educators, for open source contributors.
And also check out the workshops. A lot of people, it's just not a conference where you're going to go and watch a bunch of talks, but you also learn and get some hands-on skills that you can take back to work.
Definitely, definitely. So what do you do at Google, and where did you come from? Because you've been at Google for about, a year?
About a year and a half now. So at Google, my main focus is Google Cloud, which is, a cloud platform. Mm-hmm. And my specialty is Kubernetes right now. So all things containers, application orchestration, that whole distributed systems thing. Mm-hmm. And I come from CoreOS. So before that, I was at CoreOS working on similar technology. Mm-hmm. So you can say I'm at the mothership now.
Nice. That's cool, because I kind of went to the mothership too, except I went to the Microsoft mothership.
That's cool. We're cool with Microsoft. We love what you guys are doing.
Well, we're cool because we've got, I worked on Azure, and you work on Google Cloud, but we got .NET running on Google Cloud.
That's true. Kubernetes running on Azure.
Running on Azure. So it's a big love fest.
High fives.
We want your for loop.
We sell CPU cycles.
Right. We want your CPU cycles. We don't really care where you run them, but of course you should run them on Azure and on Google Cloud.
Yeah, and there's a lot of customers who do want the ability and the flexibility to kind of compute what they want, whether it's their own laptop, their own data center, or the cloud provider that makes sense.
So when, a couple of years back, when, you would get kind of tied to a host, and we always talked about vendor lock-in, do you think that the rise of containers was, as well as the many other problems that it tried to solve, a way to get away from vendor lock-in? Because it seems like you could really, if you wanted to, not be locked in to any particular cloud right now.
Yeah, I think the VMs were just too low level. A lot of people were coding apps directly towards the VM, and that was really specific on where you were computing. Mm-hmm. And now that we have that other layer of abstraction, thank you, Docker, taking a container image and saying, hey, here's my code. Let me point it at a runtime and not a cloud provider.
Mm-hmm. Do you think that Docker is going to become like Kleenex? Because we don't buy Kleenex anymore. We buy Kleenex, but we get it at Costco, and it's just generic tissue.
Yeah, I think that happened about a year ago, to be honest. From my perspective of just seeing how things unfolded very early on. Now we have like the OCI, so the Open Container Initiative started by Docker. Mm-hmm. So you kind of have this container image format, container runtime standards, and a lot of this stuff just comes from the OS. Right. So if you look at what's done on Microsoft on the server side, have their own container implementation. Linux has theirs, and pay homage to the people that came before with Solaris zones and so forth. Mm-hmm. Now those things are codified into this open container standard where you can say, hey, here's how you package an app. and here's how a runtime can consume it and run it wherever you want.
And do you think that that's just going to continue, that we're going to have, this will be a standard the way that, well, like, I'm trying to think of other standards now, like HTTP, we just take it for granted. Nobody
or ELF binaries, right? Like the things that just run on Linux. You don't even think about them anymore. EXEs on Microsoft.
Yeah.
These binaries just tend to work wherever that platform is. And now you can just go focus on building apps. And I think we're getting close to that now.
Right. And if the underlying libraries or the underlying runtime is there, then everything is cool.
Exactly. Because the pace that you can actually move some of this container technology, it feels like it's fast. But I think what we're doing is figuring out how do we standardize it versus, it's always changing.
So there's standards that are arising over the last 20 years, but there's also standards in architecture. So you talk about how VMs were a little too low level. 20 years ago, 15 years ago, when I first saw my first virtual machine, I thought that was a miracle. It was VMware. It was running Windows 3.1, right? And then we would go and build 3-tier architecture. Like that was the thing, right? You'd have web, business layer, and database. And then if you were running that in a virtual machine, then that was amazing. You were ahead of the game. But now, we've got web farms we take for granted. It's a checkbox, right? Databases. Now there's, if you look at something like Zeitz Now, the new cloud, I asked, Guillermo Roche what was going to be the back end for that. What's your database solution? He's like, oh, well, that's solved. That's not our problem. We could use Azure Document DB, or we can use Mongo in the cloud somewhere. Like, we don't even think about that. So like there's a cloud provider that doesn't even think about their database. You know what I mean?
And I think that has to be the case now. Back then you could actually fit your database on a single server and maybe scale up a little bit.
There you go.
But at this point you're at petabytes of data.
Right.
You're not trying to handle that yourself in many cases, or you can't even buy that much storage on-prem for a lot of people. So I think what we're starting to see now is that your customer expectation, even if you're like a 5-day-old startup,
right,
they expect you to be, global day one. So now it's much easier just to say, you know what, we're just going to go and start with this massively scaled database thing. And we're just going to focus on building our app. And anything short of that, you can't do that. You're not going to make it.
Is there any reason to run on-prem anymore other than maybe data governance?
I think so. I think if you're good at it, if you're
already good at it.
If you're good at it, right? If you're a Facebook, if you're a Google, if you're a Microsoft, you're good at this kind of thing, and you have some incentive to do investments up and beyond what's necessary right now. So I think for most people, it's probably not the thing you want to get good at before you start making money at your core product.
That's a good point. That there do seem to be some incorrect priorities where it's like, all right, let's make the great new startup. But first we need to go and write a new JavaScript library or a new container orchestration library or whatever. Like, is that really what our core competency is?
Yeah, I think humans just have that problem, right? Like, you want to be busy. So it's really hard to figure out what your customers want. That takes a whole different skill set, product market fit, talk to customers, listen to customers,
right,
build and test things. But in the meanwhile, you can just start throwing up infrastructure. Hey, let's try this new tool. Let's add this. Let's rewrite this part. I wanted to try that new fancy database. And that just keeps you busy until you get to the point where you have to actually slow down and focus on actual business value that you're selling to people.
Yeah, I think sometimes we as software engineers forget that we are in the business of business, not the business of software.
You want to pad that resume.
Yeah.
You got to put those new bullet points on there.
But that ends up being like, we talked about yak shaving, right? It's like, what are you doing? Well, I got to move to that new fancy database. Well, that doesn't have anything to do with our business. You're just trying to shave that yak.
And I think that's kind of that difference between, we talk about like senior engineers, even though I don't like to use like senior, junior title. But mature. You can kind of tell the maturity level when someone says, no, what do we actually need to get this done? Let's get that out of the way and go focus on the real thing.
So in a world of containers where we don't have to think about our cloud as much, we don't have to think about scale, we don't have to think about load balancing, stuff like that, it seems like we're almost turning the containers into tiny little services, little mini services, little microservices that remind me a lot of the Java RMI objects and the COM remote objects. How do we make sure that we are building on and standing on the shoulders of giants and not repeating the sins of the fathers and mothers?
I think the first thing is just to make sure that the container movement shouldn't be tied to the architectural pattern. So like microservices is a great idea, and that's a decision you should make independently. But, sometimes it makes sense for a monolithic application to still benefit from a container. If you think about like the mobile device, you have these large binaries that are self-contained. So that way some user can visit an app store, click the button, download the application, and not worry about dependencies. We just want the same thing on the server side. Whatever app you're building, it should just be self-contained. Whether that's a monolith or microservice, that doesn't really matter.
Okay. So do you think that people are conflating the terms microservices and containers and they just swap the words out whenever they feel like it?
All day. I mean, I think that's the number one thing. You see a customer like, yeah, we're going to go to move to microservices and this new tool at the same time. And I think the trap there is they can't tell which one is broken. Is it the new tool or is it the wrong architectural pattern?
Okay. So then it makes me feel like the question that's not being asked is why? If somebody says we're moving to microservices and Docker and we're going to use Kubernetes, and it's like, well, wait a second. You can do all or one or two or three of those things, but they aren't all required. Like you don't have to do microservices just because you go to containers.
Yeah, and I think once you go to containers or microservices, one of your biggest problems is going to be dependency management. How do you make sure that each of the services can actually live in an independent way? They may have common dependencies. Some services may scale and move on before others are ready. You might go from Java, 1.6 to Java 1.7 for different services. How do you manage that in a way that supports the business? Different teams are working on different services. So this is where containerization does make sense, right? But it's not a hard requirement that you move to containers while adopting microservices.
Do you think that people are using containers too naively? I've seen some people go from one virtual machine to one container, and they think that's a success.
Yeah, I think a lot of times in the container world, you lose a lot of the tooling that you have in the virtual machine world. Like if you're on a Linux machine, you have RPM and you have the RPM database to tell you, hey, there are some things that need to be updated on the server, run a command, they're all updated. But I think a lot of people are, when they go from like one VM to a container, those tools aren't running anymore. It's just your app. So do you really need to update those libraries or not? Who's going to tell you that?
Right.
And there's also a licensing problem. We don't really think about this anymore. When you boot a virtual machine, it comes with an OS and it's usually licensed appropriately by the cloud provider or your infrastructure. But when you move that to a container, you're now distributing that operating system with the app.
Interesting. And then when you think about, I hear a lot about Alpine. Is that I don't even know where Alpine comes from. Who makes it? Is it production appropriate? I don't know. Maybe Alpine's only good for dev. People go, oh, look, it's Alpine. It's only 8 megabytes. That's great. I didn't, and I'm just I know I thought about it in the back of my mind, but now you just brought it up to the front. And I'm like, do I go into production with that? Yeah,
exactly. So I think I like the movement of pushing more towards the developer, the person responsible for making the app.
Right.
So they can self-contain everything. But when they bring in a bash shell that they may or may not need, dependencies that they don't know about, there's a big liability cost there. Right. And it removes, other people in the org may be able to see and have visibility into what did you bring in? What is in that thing, and is it safe for me to update it? Yeah, that is a good point. And I think that when you bring in containers, the fact that you can just change the from line of your Docker file and suddenly a whole extra stack showed up can be a real problem. And then one of the benefits of containers that people don't really talk about is that you're only shipping what you need. Like from a tree trimming perspective, you want to shake that tree as much as you can and have no bytes that are unnecessary running in production. And you're starting to see a lot of build tools help with that. So over the last 4 years, I would say people understand this problem. They recognize this problem, especially when we went towards the enterprise. It was like, oh, what's the license for everything in that container? Right. Once you're tasked with that question, then you start to say, well, we need tools to help us with that. So you're starting to see tools come up that show you what's inside those containers, what needs to be updated, and actually giving you the, tools to actually make it happen. Okay. So that maturity though isn't quite there the way it is with virtual machines. Like we have tools that can tell you everything about virtual machines inside and out. But with containers, like someone was telling me about a problem where they had some 7 or 8 container orchestration system and they were having a crash in production and they wanted to do some live debugging and they didn't even know which container was having the problem. Things were jumping around. Yeah. So this is where the orchestration frameworks come in. Okay. On the container front, it solves the packaging problem. How do I get my app, all of its dependencies, in a single deployable item? Once you got that, you got the PlayStation game on a CD. Yeah. How do you distribute it? How do you make sure that it gets to the right place? And this is where tools like Kubernetes, Docker Swarm, Marathon, and Mesos, that's where they come in. So when you do have a problem, they tell you exactly what container is crashing on what server that is crashing on and giving you some tools to debug. Okay. And these orchestration systems, what are the responsibilities of an orchestration system to decide when it's time to scale out? Yeah. So the main thing of an orchestration system is to provide that abstraction. So with virtualization, we give you an abstraction over the machine. So let's not pick the machine anymore. Let's not worry about the physical network cards or disk. We'll virtualize that layer. And I think what the container runtimes do is say, hey, don't worry about the VMs or machines. Focus on the app. You tell me what container you have, and you tell me how many you want and how much CPU and memory you need. And I make sure that stays that way. Okay. So if they crash and there's only 2 running, you wanted 3, it brings it back for you. And also gives you the visibility in terms of reporting. What's running? How much CPU are you using? How much memory are you using? Collect all the logs. So all the things that we built up over like 20 years, all the things that we would do with virtual machines, they're now just rolled up into these management platforms.
Okay.
So they just come out of the box.
How do I know? Like you just said, how much CPU, how much memory? Like, I don't know. Like my application in a container runs differently than it does in a VM, and I probably don't need 4 gigs.
Yeah. So what we've seen in my experience in production, whatever you were setting your VM, that's where some people will start with the container, right?
Really?
Like my VM, it has access to 4 cores and 16 gigs of RAM. You know what? That's just probably where you should start with the container, because you just don't know what you don't know.
I see.
And then you use the metrics. And this is why it's so important that these container runtimes are shipping metrics out of the box.
Okay.
You can say, hey, you're only using half of that. Then these runtimes make it easy to go in and say, all right, let's just bump that down to half and focus on scaling out versus up.
Okay, I don't know how much weight I've lost. I'll just wear these big pants and then I'll tighten my belt as I learn more about
you
the
walk
system.
outside and people laugh at you. You might want to go and adjust what you're buying.
Okay, and then I honestly, I don't have to think about the real hardware, like the real CPU. Like it's all virtual in the sense of like, what if I've got, I got a Xeon over here with 16 gigs of RAM and I got an older server. Like, can I put heterogeneous hardware into a pile?
So it depends on how you write your app.
Okay.
Because if you're a performance savvy shop, you might be looking for that specific Intel instruction set.
Oh, really?
So you're going to rely on that scheduler, the thing that places where your workload should go to say, hey, I really need this specific instruction set. So then that's where the chip actually does come into play. Like Intel just released Skylake not too long ago, and it has a new instruction set highly applicable to a lot of machine learning workloads. If you write an app that uses that instruction set, it's not going to even run on the current chips available. So that does creep into the equation a little bit. Same thing with GPU workloads. But for the most part, people try to use a common set of widely deployed stuff.
Okay.
So you can go from one CPU back maybe 5 or 10 years and going to be good. But you got to pay attention to if you're hyper optimized.
Okay. And then certainly if you did have a machine that was made yesterday and a machine that was made 5 years ago, you might say, well, gosh, every third hit, my application is slow. It's because we're hitting containers on slower hardware.
Oh, exactly. And that's the trade-off you're willing to make, right? Because you want that ability to scale out. So really the goal is to think about how many requests per second do I need to do on this particular web app? Or if it's a database, how much work do I need to be able to handle and scale up accordingly?
Now, it seems like people also forget that the move from virtual machines to containers is a move from a mutable to an immutable environment. And I've seen people just start writing stuff to disk and then stuff gets lost and like, where did it go? Like, well, you can't, it's a read-only world in the container world.
So I think that's kind of almost a misconception in some ways. You benefit a lot from containers if you adopt this philosophy around immutability, meaning that if whatever you write, you're okay with it being ripped from underneath you and you being moved to another machine, then you get all the benefits.
Okay.
But if you don't do that, it still works. So if you think about what the container does, it just gives you a bit of isolation from other things on the machine.
Okay.
If you want to write to disk, that's totally fine. It's just that by default, most of them are writing to these temporary file systems.
I see.
And that's what catches people off guard. So if you really want to write to a persistent disk, things like Kubernetes, for example, when you launch your container, you'll say, hey, my cloud provider has this block storage. Carve out 100 gigs of that and attach it to this container at runtime. And at that point, your data follows the container as it moves around.
Okay. So let me see if I understand. There's let's say I'm making an expense reporting application. People are going to start uploading PDFs. Works great on my local system. And it drops that thing in /mount/C/whatever. Works just fine. I throw it into a container. I start losing my stuff. I would mount S3 or mount Azure Storage to the same place. Could all of the containers then share that? That's a kind of a virtualized global file system at that point?
Yeah. So, I mean, one way we, like to think about this is we're all used to this POSIX world. I have a file system and I can write to that file system. Then it gets a little tricky when you start to deal with things like NFS, where you can actually have a shared POSIX type file system. But what we've been migrating to over the years is like this idea of object store. Why even write it to /var data? The goal now is to say, just use an object store. That way your app is decoupled from the machine. So it's less about immutability. It's where you're storing your state. We're used to this, right? This isn't a new concept. You have a database. Throw that into SQL Server, and that's where that data will live.
Okay.
If you get an upload of a file, put that in the object store where it's going to be persisted and live longer than the machine.
Doesn't that mean, though, that I'm adding like the overhead of HTTP when I could just write to the file system? Or is it the fact that if I write to this file system, somebody else is just going to HTTP the thing over to S3 anyway? So
yeah, for the most part, you got to back this data up.
Yeah.
You got to replicate the data if you really want to see it ever again. So I think we're getting like the best of both worlds by standardizing on a pattern. Hey, let's take the hit on the object store. And there's all kind of ways people optimize this. You can cache it.
Throw it in a queue.
There's all kind of things you can do. It's just a best practice that has evolved over time.
Okay. How much granularity should someone have when they're maybe starting to move something over? If I've got a product catalog and a user identity and I've got a shopping cart, there's kind of obvious 3 microservices there, but maybe I could break it up smaller. Maybe I don't need to break it up. How do you usually kind of partition that?
Honestly, I tell people move it as a monolith first, straight up. And then measure. If you tell me that the app is slow, you got to be able to tell me why. You got to say, well, the slowest part is the checkout piece. And if you can prove that with some graph or some logging, then I say, how about we rip out the checkout piece and scale that horizontally? And then that's just the right thing to do. So I think most people just go with some scientific method versus the fashion of microservices, and you'll be in good shape.
It definitely seems like I hear that people are going with their gut rather than just simply measuring. And if they would just start measuring, life would be a lot easier. All these questions would get answered.
Then it makes sense to your colleagues. Like, why'd you do that?
Yeah.
Right? Like, why did we break this piece out? And why is it causing us pain? It was totally worth it.
So if I've got a large, or I'm starting to break up my large monolith into little pieces, how do they know the names and the DNS of the different ones? Like, let's say that you hit the product catalog and then the web app decides that I'm going to put something in the shopping cart. I could have 1 shopping cart container. I could have 6. Do I talk laterally from product catalog over to shopping cart? Or do I go back out to web and then back down? And how does that work? How does that's like orchestration for me.
Yeah. So I think that's a part of orchestration called service discovery. And I think the first thing that most people run into is you break your app into all these distinct parts. And it's easy if there's only 1 copy of those distinct parts, and then you just kind of know where they are. But what happens when you start to scale one of those components to maybe 5 copies and you throw a load balancer on top, or maybe you're talking point to point. So most of these orchestration platforms will include service discovery.
Okay.
You say, I want 3 copies of a thing. It places it on the right machines, gives them an IP address, and then records their location and presents it through something like DNS. So they can use the standard protocols you know and understand. Hey, I want the off service. That will either return you a list of off service IPs, SRV record, or maybe an IP of an internal load balancer. So you can just focus on hitting that.
Okay. So does that mean then I'm in the product catalog and I'm about to send something over to shopping cart? I might have in my application shoppingcart.kelsey.com. That is another load balancer. So I have like a series of load balancers. Shoppingcart.kelsey.com might be an internal DNS entirely that talks to N number of shopping cart Docker containers, but I just don't even think about it.
Yeah, we want to move that whole how the internet works into your infrastructure, right? Okay. So if you go to google.com, you don't know how many web servers are serving up that search result. All you care about is that there's one locator to make that happen. And then that gives flexibility on the people managing infrastructure to re-IP, move things around, resize them without going and touching a bunch of applications.
That seems like such an obvious, clean way to do things. It seems like 15 years ago, 10 years ago, we had like WS ***, and we were doing service discovery, and we were looking up catalogs to get GUIDs of URLs. And I'm hearing you say, well, you should just use DNS because that's a pretty good way to look stuff up.
Yeah, and I think a lot of this that we're seeing is that a lot of these tools that we've had and proven themselves, like DNS, the only thing really was missing was a little bit of automation and glue, right? So it's not like we have to toss all this stuff out.
Right.
But the patterns have started to emerge over time. These are pretty much the things that have stood the test of time, and they just get rolled into the platform so you don't have to think about it.
Yeah. When I think about REST, I just feel happy about using HTTP verbs for what they are. And when I explain to people like the basics of, how CRUD maps to these different verbs, they go, oh yeah, that makes a lot of sense. And like, in my mind, I'm like, why were we tunneling verbs inside of envelopes, inside of bodies of other envelopes, inside of a post? You know what I mean? We had this perfectly good protocol already out there. HTTP was great enough. HTTP2 will be better. DNS was fine. It really seems like we are standing on the shoulders of giants and starting to kind of tighten things up. So is this a return to kind of a minimalism?
Yeah. So, that's just one of the things that I practice in general is this idea of minimalism, really understanding like the core of what you need, right? And I think in your life and in the tech world, this is one of the most important things. Like if you're storing data, you need a database, right? And for most people, standard SQL gets the job done. But I think people get confused with the hype, right? If you're like, hey, we got to pick a database, let's not pick an old database. Let's get the new database. Whether the new database works for you or not, most people aren't making a decision on what you actually need. And I think having that kind of sense of responsibility, what do we need? What is the smallest thing we can do? Let's just do that and then measure and then figure out if we need something else.
It's like people say, Postgres, that's so 2000 and late. I want to do NoSQL. It just seems like you're right. They are picking the new hot thing, but that is not battle tested. It sounds like you recommend maybe finding a balance, staying a couple of years back on things that you have seen battle tested, especially if you're doing a startup.
Or make sure you understand the fundamentals. Like, why are you making this trade-off? If you see some new technology, ask yourself, what problem is it trying to solve? If their documentation or the project creator can't answer that question, you should be nervous because a lot of people are building stuff and they don't know that they're reinventing the wheel. I once heard a saying, it's like, let's not reinvent the wheel. But what happens when people start rhyming, right? They don't know that they're reinventing things. It just looks the same. It's similar.
Start rhyming?
They start rhyming, right? So one thing you don't want to do is repeat yourself, right? We have this dry principle.
Right.
Don't repeat yourself. But what happens when you're just rhyming? So you think you're saying something different, but it's close enough to being the same thing.
Oh, okay.
Right? So if you pay attention to what you're building, it's like, hey, do you know what that is? You just built DNS, but badly, right? So I think as people understand the foundations, they actually start to choose the right technologies and know that they're on the right path.
That's interesting. I've never heard that referred to as rhyming. That's cool. I got to think about some ways to express that. That's good. I like that. One of the things this makes me think about, though, is I have been lowercase a accused of ageism, mostly because the older I get, the more I look back on some of the things that some younger, very smart people are doing and going, God, I'm pretty sure we did that in the 80s or the 90s or the whatever. But of course, I'm going to say my elderly, opinion is sometimes dismissed, or maybe I inadvertently dismissed theirs. How do you find that balance between that new amazing innovation that we see from the young 20 somethings, as well as the I'm not going to put you in the older category, but certainly you have a lot of experience in this space. How do you keep yourself how do you find that balance between innovation and respecting the powerful technologies of the past?
I'll give you a good example. When I joined CoreOS, this was probably the first time I was dropped into the deep end of distributed systems.
Okay.
So etcd comes out and what is this thing?
Well understood science, to be clear.
Well understood science. So I'm like, in order to get up to speed with this, I just went and found the old white papers. Like, what is a logical clock? You search for that, you're finding like Leslie Lamport. This was written, a couple of decades ago, and they're explaining it really clear.
Right.
So I think for me, I just learned to respect that there are people who've researched this stuff.
Yeah.
If you just go read it, you can get a lot of the foundational bits. And I think it's more of a respect thing, right? It's not about knowing everything. It's about being able to leverage a lot of work that other people did, so you can actually go and build a new exciting thing based on that foundation that's solid.
I was at a conference. I want to say it was Oslo. We were at some dinner. And I was sitting next to this elderly gentleman, and we had just released ASP.NET MVC. So he says, what do you do? I work for Microsoft. What do you work on? I work on MVC. And he goes, oh, MVC. I invented that. And I'm like, what? So I go and I Wikipedia the guy. This was like the guy who invented the MVC pattern in 1976. He was sitting next to, he's like a famous Scandinavian guy. And I felt like such a dork. Now, fortunately, I hadn't said anything dumb yet. But I had just told him how excited I was about shipping an MVC pattern, and he had invented it when I was 2.
And I think that is like the superpower, that if you're in tech, if you understand that one part, that if you go research all the way down to the foundation, you'll look like a superhero because you're actually focused on the right things versus running around looking confused. And there's nothing wrong with that. Like understanding that there may have been people who have solved the problem before you. Right. Taking the time to study before you start any strokes on the keyboard.
Right. This doesn't mean that everything has been solved or all the problems have been thought about, but the Gang of Four had something they were doing that was pretty thoughtful, and we should look at their patterns and we should think about those things. Distributed systems, it's smart that you recognize that was a well understood science with some foundational technologies that we didn't need to reinvent.
That's right.
That's interesting. So when people are totally overwhelmed and they hear all these buzzwords and they go around Googling, they're going to find whatever Google comes back, with all due respect. It might be some random person's loud blog. How do you know what's right and what's smart when you're going to go and start getting into the world of containers and large system orchestration?
So for me, the tricks that I use, I Google and I look at the names, right? You go to the GitHub projects and you look at the names.
Okay.
And a lot of times these people, even though you may think very highly of them, they're actually reachable, right? You can ping them, you can email them, usually available on Twitter or some Slack channel IRC. And they're really happy to talk about the thing that they're working on. So if you want confirmation of like your understanding, I will reach out to people and say, hey, I'm using your particular project and here's some things that I'm thinking about. Here's what I currently understand. And if you give some well thought out questions, you usually get well thought out answers and response. And I think people overlook that ability that you just don't have to rely on search results. You can actually dig deeper and do the human thing.
Yeah. And I would also add to that too, if they do happen to be conference speakers or people who speak at conferences, yourself included, watch their videos.
Watch their videos because we're always interested to give our real world kind of opinion on things. And I think that helps guide people to their light versus the marketing material.
Definitely. And on a personal note, I definitely look up to you as a presenter. You have a style that I would like to emulate as a presenter. And I really enjoy watching you talk because you're excited, you're kind, and you empower the audience. So I appreciate you as a conference speaker.
I appreciate that, Scott, coming from a well-renowned speaker that I love to watch as well. Thank you.
Thanks, man. I appreciate that. Well, thanks for coming on the show, man.
Awesome. Thanks for being here.
This has been another episode of Hansel Minutes, and we'll see you again next week.